It's September 27th, 2019, and you found the latest episode of Thinking Through Autonomy. Today's show was inspired by one of those once in a lifetime moments where you come across the technology and realize, hey, this is important and this could change things. I had that experience and those thoughts at a presentation in July at Noblis. What I'm talking about is a technology called Pieces of Eight, and Pieces of Eight combines blockchain and trust to create a collision avoidance and trajectory system that can deconflict the paths of autonomous vehicles. Its maker calls this orchestrated autonomy. And in fact, it's winning awards all over the world in 2019. We'll be talking with Dr. Karl Wunderlich of Noblis, its driving force. Our conversation spans measuring performance in a surface transportation system, the essentials of blockchain and shared trust that serve as the foundation of Pieces of Eight, how Pieces of Eight works, and how this system incentivizes manufacturers to build highly reliable autonomous vehicles. All this and more. Stay tuned. Welcome to Thinking Through Autonomy, a podcast to help you understand the promise and impact of autonomous land and air vehicles in our world. I'm Ken Dunlap, managing partner of Catalyst Go, taking you on this journey. Hear and read more at thinkingthroughautonomy.com. Now it's time to take your hands off the wheel, foot off the pedal, hand off that throttle, and let's go. Karl, welcome to Thinking Through Autonomy.
Great. Thanks, Ken. Great to be here.
You know, since you and I first met in July, you and your team have had this really incredibly big year. 2 weeks ago, your team received the prestigious Government Industry Innovator Award, and that was from the 1105 Public Sector Media Group for something we're going to talk about today called Pieces of Eight. And that's already on top of these two awards you had. One was the Highest Potential Impact Award, and the other, the Most Creative Award. And that was given to you at the Moby Grand Challenge in Munich. And so I'm just wondering, how are you going to top that? Or are you just going to take the rest of the year off and say, mission accomplished?
Wow. Well, thanks, Ken. I appreciate that. It's been super busy, super exciting year. But at the same time, we've really done a lot of great stuff. People have been very energized by some of the stuff we've been talking about and the demonstrations we've been able to mount. So I feel like, although it's been super exciting year, that I feel that I have more energy now to take it on because we've gotten such a positive response.
Well, I can't wait for the more to come that's coming. Now, all of these awards that we're talking about were for a concept that you and your team have developed called Pieces of Eight. And that involves something that we're going to really dig into called orchestrated autonomy. And that's a concept that involves blockchain and shared trust. And I just want to start building for the audience kind of the foundational pieces for Pieces of Eight. And I'm wondering, Karl, can you tell us, how do you go about analyzing the performance of a big complex organism like a transportation system? And how are we doing it in a system right now where clearly autonomous vehicles aren't running up and down the roads on anything but a test basis?
Right on. That is a great start. And that's really where I started my career in transportation, looking at it as a large, complex, integrated surface transportation system. And well, the first thing that I noticed, because I came from a slightly different background in logistics and manufacturing floor operation, where you measure efficiency by how many sort of pallets of material gets moved through the system and how many widgets or product gets moved out at the end. And the first thing I noticed when it came to surface transportation was that was not what was getting measured, because it was too hard. It was too hard to measure how many trips were completed or how many cars actually made it from one point A to point B. And they really the basic building block for performance were based on things that were strange to me, like byproducts of the system. So right now, I think for the most part, we still spend a lot of time worrying about things like crashes and fatalities, which we need to, by the way, and how much stuff gets thrown up in the air, like the emissions and so forth, how much fuel gets consumed. And because those things are the things we can measure. And so the problem with such an approach is that, for example, if you wanted to reduce emissions and fatalities and crashes to zero, I have a bona fide way of making that happen, which is to chain everybody up in their house. chain everybody up in their house. Don't let anybody use the roads. And then by definition, there'll be no transportation-related deaths or pollution. The problem is no one will get to go anywhere, and we'll all starve there because no food will be delivered to the grocery stores. So inherently, anytime that we have a big system like this and we only measure these byproducts, there's a bias in the system to anything that suppresses demand or utilization of the system produces less of these byproducts or externalities, and so that felt was a real problem, a real problem. And so some of my early research when I came to work on the transportation problem revolved around trying to count things that mattered, like, for example, ability for people and goods to move reliably in the system and get from point A to point B in a certain amount of time that was consistent with the thresholds seen in the past, like the amount of variation in travel time seen over the last year or so.
So, Karl, what are some of these core metrics? You mentioned one, reliability, but are there others that you pay attention to as well?
Oh yeah, absolutely. So the golden target for this we've always been seeking is really an effective measure of throughput or productivity or economic productivity associated with the travel in the system. That's the goal, the holy grail. That's the thing I was looking for. The holy grail is to look for that. But it's been too hard to measure in a world of where you don't have connected vehicles, so that you don't have a ubiquitous connectivity of the entities in the system, like we would, for example, on a manufacturing shop floor, right? You can track the pallets with barcodes and so forth. Anyways, so the point is that throughput is super important. What happens at bottlenecks? How many folks can get through, and are we doing better today than we were tomorrow? And under what control systems are we actually improving the system? That is the goal, and I think we're getting closer to that with sort of connectivity with the vehicles, but we're not quite there yet. So predictability and reliability is important for trip planning, for people to know that they can get to work on time, or they can get back home and pick up the kids at the end of the day from daycare without getting fined. That's actually trying to be a big driver in our reliability studies. In any case, so it's reliable travel times for those who use the system, and then if you take a look at it from the system perspective, measuring and increasing throughput in a disciplined way seems to be something we're still trying to get to, but we're getting closer every year with ubiquitous connectivity with the entities in the system.
And if we should throw autonomous vehicles into the mix, does that necessarily change the type of metrics we're going to look at? Or are these metrics independent of who or what is operating the vehicle?
Well, arguably the metric should be the same. So I think that's an interesting point. The how autonomy fits into the system. We still should be trying to move goods and people and make that travel predictable, and trying to move the largest amount of goods and people with the smallest amount of negative byproducts. That is, fewest amount of fatalities and crashes, the most limited amount of environmental damage from that activity. So I think that remains the same. But I think what changes is the way and our ability to influence the system. Rather than trying to influence the system through human behavior, we have an opportunity to rewrite the rules of interaction so that the system itself potentially can be much more productive.
Karl, one of the things that you've written about is that in this effort to take a look at how these transportation systems perform, there are really, I'd say, two entities that are involved in this mix. One is the large organizations who may have a mission to watch their fleets or watch their roads. And the other one is the individual analysts who are doing the job and really putting the piece of paper down and putting the pen down and coming up with the metrics and the analytics and the story of what's happening. Yet you mentioned that individual analysts and their capabilities are often outperforming that of their organizations. And as a result, this kind of information gets siloed. So I'm wondering, did I describe that correctly? And how do we break down these silos so that information is shared not only within an organization, but all the organizations that depend on that transportation network?
Right on. Yeah. So yes, one of the shared infrastructure that is sort of our roadway / surface infrastructure. Essentially, it's a marketplace. It's a shared piece of infrastructure, and so anytime that we have cooperation and competition over shared infrastructure, the lack of information or the siloed effect that you're talking about always leads to inefficiencies and sort of increase these externalities, these negative byproducts, and a lower efficiency and productivity of the system. And so we have, I think, over time, like when I started my career, one of the real key technologies that we were looking at was just travel information. How does that change the system? How does providing travel times, for example, on roadway systems and color-coded maps. How does that actually change and make the system more efficient altogether? Because in that sense, just as you pointed out, the breaking down of the silos, providing everybody with the same information about, for example, travel times, turns out to be actually a great leveler. And in fact, I would argue that even today, the most powerful piece of control that anybody has to make a system more effective is the use of travel information or just information inserted into the system.
One of the things you also wrote about, Karl, is that seemingly we're losing our grasp and our knowledge of the past performance of these transportation networks. And to me, that kind of seems counterintuitive because you'd think, well, I could take all my knowledge and I can put it on the cloud and anybody can have access to it and they can have it for as long as those electrons are running around the storage devices. What's that relationship between the lessons we've learned in the past and the ones we're going to need to formulate and the practices we're going to need to employ, in the future, whether it's for a drivered or driverless car?
Yeah, right on. So, yeah, so I think there are some important lessons from the past in that when folks try to make localized improvement, then they tend to discount the impact that might have at the system level and how other people might react to it in the broader system. So this like ripple effect. And so I think that is absolutely one of the key lessons in the past that we need to be aware of as we move into a sort of a newer realm where data is more ubiquitous, where connectivity is relatively ubiquitous, and then autonomy becomes more and more prevalent. Absolutely, I think if people begin to think about only trying to optimize or sub-optimize one particular element of a network, they may lose the sight of what effects happen outside of that. And I think we can see that with some surprising results where roadways have actually been improved and widened, but then actually downstream it creates a bottleneck that is even more entangled and has lower capability to deliver throughput. And so the system, even though you've just spent millions of dollars, actually the system itself, its ability to transport and move goods becomes less reliable, or it's only more productive under very specific conditions where demand can be metered. In any case, we've seen that already. We've seen that in the past with highway improvement projects, and new technologies been inserted, new adaptive traffic zone control systems that in the end seem to have a negative effect outside of their own little area where they've been put in. And I think that is critical when you talk about the onset of the ubiquity of connectivity and the increasing autonomy within the system. I think we're going to see a lot of that, where if people are not looking at a sort of a holistic or a system level assessment, we may end up making things actually a little bit worse than they were before, even though we might have just spent millions or billions of dollars in an attempt to solve the problem.
Sure. I really want to talk about pieces of eight now. I think we've got a pretty firm foundation. Last July, you and I met, and I saw your presentation in Washington. And that was, for me in my professional career, one of these aha moments. I saw what you were talking about, and I said, the implications of this go far beyond driverless cars. In fact, it can probably go to any autonomous system. And let's give our audience a grasp of that future. And we're going to post one of your videos on your show notes page. So folks, head on over to Karl's show notes page and you can get a video depiction of what we're talking about. Karl, let's just start with defining what is the problem. And I want to put the problem that Pieces of Eight addresses within the larger context of all the problems out there. And I'm wondering, when you take a look at autonomous vehicles, and you see this whole range of problems that they face when they're in a typical surface transportation system. What are they? What's the range? I mean, what's the range from the most minor to the most catastrophic, and what are the common ones? Where does the problem you're attacking fit in this entire spectrum?
Right. Well, since I am a system level guy, and we talked a little bit about our worldview with respect to how does a system work and how could it be improved, and what are the implications of transformative technologies like autonomy. One of the key, I guess, problems or concerns I had when I viewed the the very inspiring and terrific and amazing and engineering and scientific work that's going into making our vehicle fleets potentially driverless and moving up the levels of autonomy from the lower levels that we're used to now to something higher. My concern, I suppose, was looking at that I felt like a lot of effort was being made to mimic the human driver. It's essentially make the autonomous vehicle or the automated driving vehicle essentially the best possible replica of a human driver, the safest human driver on the roadway system. And my concern about that, given that I've looked at some of these big networks and I've seen the impacts of small changes, for example, in headways or throughput, it's like a major at bottlenecks, like a bridge or something like that. They can have amazing ripple effects, negative ripple effects throughout the system. And so, although these autonomous vehicles are amazing wonders, I was concerned about their potential interaction at scale in a system that I knew had a fair amount of unreliability or uncertainty in it, and essentially particularly brittle or fragile aspects of its capability to be productive. Anyway, so my bottom line was that if I looked at some of the papers and the performance of the automated vehicles or the autonomous vehicles driving, especially together, they tended to produce harmonics in the system and produce traffic flow that were different than with just regular human drivers. And in fact, if they needed to be more cautious, they would definitely do so to be safer. And the result in the end was all those billions of dollars potentially, and we have simulations of such large systems causing traffic that was or traffic congestion 3 to 4 times as bad as they are today with human drivers, just because of the nature of what potentially those autonomous vehicles that are driven towards a point of approximating the best human driver in the best case, having to interact in a system designed for and around human driving skills. And I've used this a metaphor before, the idea that you have a digital signal and then you transform it to an analog one, then back into digital. Seems like you'd lose a lot of the value potentially of moving to a digital signal. So that's kind of my analogy or metaphor for this, is that letting machines drive like machines would use a system without having to go through this prism of intending for all of them to drive like the best humans, might produce a system that was different, potentially more robust, potentially more productive than what we have currently.
Is that another way for saying that if I wake up 20 years from now, I shouldn't expect to see the same kind of system performance and the same kind of traffic as I do today, because we're going to let the machines do what they do best and let humans do what they do best?
Yeah, right on. Yeah, that's a great way of saying it, Ken. I mean, really, I think if you wake up in 25, you could wake up from in a utopia in which I think there's a potential to make it so that things are much more efficient, that goods and people are moving so much more efficiently than they do currently, that the system itself is far more productive with no change of right of way, with far fewer crashes and fatalities, and a significantly reduced sort of impact on the environment. Or so like that's like the you wake up from, and it's the positive day. I think there's also an alternative if we don't get our heads around this before technology kind of overwhelms us and we find ourselves in a spot where we can't easily go backwards and redo what we've done. We may end up in a spot where all the technology, all the investment essentially results in the same or a worse condition. And I would offer that potentially it is a worse condition if it's not managed correctly than what we have right now. That people will essentially try to just convert the time that they spend traveling and the use of autonomy into something that it looks more like free time, or but is essentially no more efficient. So that would be the only gain we got out of the system. The traffic may actually be worse, but we would offer up, well, now you'd be able to do something else with that time, like listen to an excellent podcast or to watch television.
I like that
or
idea.
something. Yeah, but I think that, although that itself may be at the margins more attractive than what we currently have, I feel like we would miss the transformation that is really that was within our grasp, and I would argue almost easily within our grasp in the next 15 years or so if we get it right. But if we don't have the right trajectory, if we don't set it up now for the right trajectory, we will. I think it's probably more likely than not that we'll just end up in the realm where it's about as efficient as it is currently, and it's slightly more convenient for the user. Whereas I think we have the opportunity now in the next 15 years to make a system that is potentially as much as 4 times more effective with no crashes, with a very limited environmental impact. But the requirement in this case is that we allow the machines or these autonomous machines to self-organize and utilize the system in ways that are unfamiliar and potentially not an analog or a metaphor or some dim remnant of the way we used to use that system when it was all humans.
Well, you just described pieces of eight, didn't you?
Well, I figured we were going to get there at some point, so I thought I'd bring it
Yeah.
up.
So, yeah, pieces of eight you describe as being based on blockchain and shared trust, and it results in something called orchestrated autonomy. Let's kind of maybe break this down a little bit for our listeners. Can we just start with some of the basics and helping me out too? When we talk about blockchain, what is blockchain? I mean, should I be thinking of Bitcoin or cryptocurrency? And what is shared trust?
Yeah, right on. Okay, so let's start with blockchain, and it is one of the fundamental underpinnings of I think our opportunity to do this transformation because of the nature of what it is. So let's set aside what people think are about blockchain in terms of being just a cryptocurrency like Bitcoin for the moment, and talk fundamentally about what it acts as in any system where it's used for a general purpose, right? So at the center of the blockchain technology is this concept of a distributed ledger. So essentially, a distributed ledger is a big spreadsheet, and that's one way of talking about it, that everybody can look at the same time. Big open spreadsheet, and it has a couple of different attributes that are particularly useful when you're trying to coordinate a collection of individuals who need to transact and have limited trust with each other, but want to ensure that all the transactions are recorded correctly. So in this case, the simplest metaphor that I use for blockchain is that it's a shared ledger, and once you have rules set up about how things go into that ledger, the new entries are appended sequentially, so it only builds forward. And if anybody tries to go back and mess with that ledger and say, well, okay, 4 transactions ago, Ken and Karl, we had this agreement that Ken would pay Karl for, or if there was some agreement for a transaction, we reversed it and said, now, okay, now instead, the payer becomes the payee, and like that was like a piece of trickery. The cryptographic encoding of that particular of the blockchain and the distributed ledger shatters the entire thing. So that copy is clearly identified as being different. So we talked about it before as being sort of a shared ledger or distributed ledger. Well, it's not just one ledger that everybody writes to. It's a ledger that everyone keeps a copy of that has a stake in the system. And when one copy looks different than the other copies, it's immediately overwritten as being erroneous. So in this case, my ability to insert something false into the transaction history becomes very difficult to override. And there are ways of doing it, but I think we'll just avoid that for right now. In terms of the cryptographic security, it's a great way of having a collective view of a single resource. And as long as all the stakeholders are sort of paying attention to it, it's very hard to corrupt. So if the game is set up correctly and the distributed ledger is set up correctly and the transactions are clear, then multiple entities who have a stake in the system can look at that ledger and ensure that what is there is real and reflects the reality of what's actually happened in the system according to the rules that have been set up.
And I suspect that leads us to the conversation that says if you have these ledgers, you can build trust around these ledgers. So in the system, let's just maybe dig at this just a little bit so I understand a little better. We have the ledger, I trust it, you trust it. Does that mean a third party can come in and say, well, if Ken and Karl trust each other, I can, without knowing Karl and without knowing Ken, trust them as well? So is that kind of what we're talking about?
Absolutely. And in fact, I think like something like Bitcoin. So when you do monetary exchanges, that is absolutely a form of trust, right? And that's how Bitcoin got started, because it was a way of exchanging value between a couple of entities that may not have trusted themselves, trusted each other in that group, but then another third party could enter that system and see those transactions, identify that yes, indeed, the transactions were not being tampered with, that it was a secure place to have exchange, and then enter into it. And I think that's why, for example, the best known blockchain application is cryptocurrency. But the reality of it, and I mean, almost anybody that talks about blockchain will say, is that that's just the tip of the iceberg, or maybe one, not even, because usually icebergs are like 10% sticks out of the water. Like 1% of the real useful applications for blockchain technology relates to the exchange of value and currency. Really, it's the ideal platform on which you might exchange other kinds of information and establish trust, because inherently we're talking about a trust building, just as you put it, a trust building capability, a trust building platform. And so how we exploit trust using distributed ledger, I think, is the tremendous potential beyond cryptocurrency, which is its own amazing thing. But I think, like I said, that 99% of the value will derive from distributed ledger technologies comes from solving issues around shared infrastructure by having entities, machine or otherwise, learn how to establish and share trust, share that resource using the distributed ledger as the platform that ensures trust in the system.
Which leads us to this thing you call orchestrated autonomy. How do machines using blockchain and shared trust get to orchestrated autonomy? What's the connection?
Yeah, right on. Right. So that is the that's the little piece that we're working
The
on
million
here.
dollar question.
Yeah, that's the piece we're working on here to say, yeah, can we use blockchain to leap into this and have machines essentially learn how to share the roadway surface in a way that no human ever could do. And by so doing that way, and orchestrating their movements and learning to trust each other, and to understand that machines are heterogeneous in their capability to sense, heterogeneous in their ability to maneuver, and heterogeneous in their ability to be trusted in the system, that can be orchestrated in a way that the right of way that we have for our surface transportation system now can be rethought and reutilized and potentially transformed into something that is much more powerful, safe, effective, and environmentally friendly. That is the notion. But specifically the trust element here is we use trust because it's the easiest way for humans to understand. And in fact, how we drive now with each other is based on a system of trust. It's absolutely based on the same kind of thing. But the way that machines actually, and I'll talk about this in a minute, the way machines establish trust is inherently different than the way that humans establish trust. For humans, I assume if I'm driving behind you that you have a valid driver's license, that you know that you should stay in your lane, and that if you're going to change lanes, you're going to signal the intent to do so that I can plan to maneuver around you. That's examples of all the different ways that we share intent and follow rules, and we divvy up the system in a way at a human level that we can trust each other and maneuver. In fact, we've done a great job. We have 100 years or so of shared collective experience, incrementally establishing trust in how vehicles are going to move, and we've been very successful as a species in making things about as efficient as we can, given our capabilities as sort of meat-based computing pattern recognition machines. So for creatures that were evolved to do something very different, we've become pretty good drivers in 100 years. So tip of the cap to the human species for me for doing about as well as we've done. But we are not the evolutionary apex predators for the use of surface transportation systems. We are something else that is doing the best they can. If we introduce machines in the system, it's our opportunity to say, all right, well, if we were going to do this differently and really do it well, how would we do it that wouldn't be based on the evolutionarily the kind of pattern recognition meat-based computing machines that seem to be in charge right now.
One of the things that occurs to me as I'm thinking about this, I've got this gross simplification going on in my head that what we're talking about in maybe some sense, is a social credit score for robots. And that tells me, okay, well, now I know how I can trust car A over car B. But as I see the potential and what you've demonstrated in Pieces of Eight, is that you have the ability to allow machines to express the experiences that they're having with other machines, to record that on the ledger, and then actually develop navigation solutions based on who the most effective machine is, who's the least effective machine, who's the machine that wants to pay for a high speed navigation solution. Can you kind of maybe describe what are the problems that this solves, and maybe take us through an example of an intersection or some other traffic conundrum? I've never used that word conundrum before on the podcast. That would explain how Pieces of Eight works.
Yeah, right on. So an intersection is a great example. And let's just take the example where it's all machines trying to go through, let's just say it's a complex intersection, more than four legs. I'm sure anybody that's out there has seen some of these complex intersections sort of leftover of the days of wagons and horse-drawn carriages where some of this urban form was generated, where a lot of things all come together in one location. It's very complicated from a human perspective to sort of sort these intersections out. And so there's a ton of signalization, there's a ton of striping on the ground. Okay, so let's imagine all of the things that we use to organize the humans are gone. So all the lights are gone, all the striping is gone, we don't have shoulders, we just have essentially pavement and places where vehicles can operate and where they can't operate. So in these cases,
sounds like Sweden.
Yeah, that's right, or to some place where they haven't gotten together and actually put anything in. So in some ways, it's a step backwards.
I had to throw that in.
Yeah. Well, I mean, it is funny. In some cases, the removal of hierarchical control mechanisms actually can produce, in some cases, a much more efficient system, and even a safer system, depending on who the driver is. But in this case, let's just switch our minds back to the machines for a moment. Imagine a fleet of autonomous machines. They all can sense a variety of things around them. They're constantly looking out for obstacles. Some may be larger, some may be smaller. So there's huge, like tractor trailer style things moving freight. There may be very small vehicles moving individual people or small packages, but they're all navigating in and around this complex intersection. But there are essentially no rules about who gets to go first. So how, in that case, can these machines sort it out and efficiently figure out who gets to go first and in what direction and how we're going to avoid each other? And the reason that's important is that if without any rules, the machines have to self-organize. But that essentially is the beauty of the solution, because the machines left to their own devices and a construct like Pieces of Eight essentially look out across this intersection, and then they identify every square centimeter of space of pavement that could be driven upon, and dynamically allocate that in time to a collection of vehicles who have non-conflicting paths. So essentially, they work out a set of paths where they can go as fast as they can without hitting each other. And, by the way, respecting the ability of any entities in the system's reliability in terms of sensing objects or performing maneuvers. So that's what the distributed ledger actually is used for in this case. One is to establish trust. That is, if a particular machine says, look, I see this object here, collectively the machines connected to each other in this network navigating the intersection say, all right, well, that machine has a very good reputation for detecting obstacles. And so that stuff that it sees there, I think we all need to avoid. We'll all plan paths around that obstacle. And so then they can get to the point, once the obstacles are identified, who gets to go first. And in this case, again, a distributed ledger, a slightly different distributed ledger solution, is used to say, all right, who's willing to pay the most? And then we do a little sealed bid auction among the machines to identify which of the machines has the priority. And after that, they essentially buy up the dynamic space, like real estate, right? 1 centimeter by 1 centimeter by 1 second pieces of real estate that are the same, that are sized appropriately to the trust of that vehicle being able to maneuver within that space. So Some machines don't actually do that such a great job of staying on path and kind of wander off. And so in those cases, the trust scores associated with those for maneuvering will have to buy more real estate. And so they purchase that real estate, they reserve it, they pay off the other folks for the right to use it. The ones that wait are also accrue value in this particular blockchain solution. But they work out a plan, and actually we have our little rovers in the demo that Ken saw, the small scale version of this. They can do this all in about a tenth of a second. So it's not that hard. It's not a super hard computational problem for machines once trust is established and the uncertainty can be reduced. In a tenth of a second, they can make a 10-second plan very, very rapidly. And then they can execute against that plan as long as everybody does what is according to the plan. And so this is what Ken alluded to before. If in fact one machine ruins the plan by essentially driving off or essentially out of the area that they had purchased or temporarily purchased, then the other machines in the system say, well, the plan is ruined. And so now we have to stop and replan. And we all agree that the fault is this particular machine here. And so therefore, their trust score then goes down for the next interaction. They're forced to buy essentially more real estate because they couldn't maneuver reliably before. And it's a self-regulating system. So those machines that earn trust and get incrementally improved trust scores can go faster, take on more elaborate paths, and buy less space than those who are less trusted, who have to buy more space, go slower, and potentially get dinged if they can't actually perform. So the result of all this, although it sounds kind of complicated, is that for that sort of intersection, we project that we can quadruple the amount of throughput in a system over what humans do currently. So that is a huge improvement, but it will not look like striped lanes, signals, turn lanes, and all that kind of stuff, and clear, well, now this whole platoon is going, that whole platoon is going. That's not what the future will look like at the intersection. You'll see vehicles making all sorts of maneuvers that a human would have never thought of doing and probably wouldn't feel comfortable doing.
That sounds like a nice commute.
Right, yeah. Well, you're not making those. I mean, even if you're in the commute, right, you're in your vehicle and doing whatever you wanted to. It's you farm that processing out. You farm the control out to the machine, and so it wouldn't really matter to you so much. Although I would say that another sort of nifty thing about pieces of aid is that if you're running late, you can instruct the machine to be sort of more urgent in their bidding for the space in front of them. So folks who are running ahead of schedule and maybe are not so critically concerned can essentially lay back and accrue value in the system by allowing folks who are in a big hurry to pay for the right to move through. So in some ways, the kind of dynamic pricing, congestion pricing we have on I-66 in DC, for example, and other roadways across North America and the world is a very kludgy, sledgehammery way of trying to figure out what the value of that real estate is. And in this case, it's much cleaner because the micropayments for the maneuver space are directly accrued for the folks who are displaced, essentially, right? So there's no third party that has to be entertained for that to the value to transfer. So it makes it very, very clean in terms of who pays and who benefits without any third party involved at all.
Karl, if I'm a car manufacturer or if I'm a component manufacturer, isn't this system incentivizing me to put the best sensor systems on a car so it has the highest social credit score, the highest trust score, and it disincentivizes me from having bad technology, doesn't it?
Yeah, I mean, absolutely. And I think that's one of the things that I think people have really glommed onto, been very excited about, because in a system that is organized this way with essentially productivity as the controlling function, like, we could design a terrible system using blockchain, but I think with pieces of it, we're trying to build a system of rules of interaction for the vehicles that does indeed maximize things like productivity with making sure that all this is as safe as possible and has reduced environmental impact. But essentially, it's a system designed to do the things that we need. and it has this built-in, like you just pointed out, Ken, it's got a built-in incentivization for folks to get the best technology. So you could bring your Model T out onto the Capitol Beltway here in DC, but you would expect to pay a lot to reserve all the space that you would be needed because you have no sensors, you have very little capability to maneuver your ability to accelerate, decelerate. You would be buying up huge tracks, and you'd be paying off everybody else if you were in a hurry. If you had a smaller, very capable, high maneuverability machine that could exploit essentially leftover pieces of dynamic real estate, you may be able to get through very rapidly without paying much at all. So we're incentivizing essentially the exploitation of leftover, what essentially is leftover shared resource that wouldn't have been allocated. I mean, right now, it's sort of a crazy thing to say, but right now, the shared infrastructure we have, sits underutilized, for big chunks of the day, and then it's way overutilized for very small periods of the time. But even in those points of high utilization, the density on the roadway surface is actually relatively low. There's a lot more free space out there than people imagine when they're in their cars, because we have to have space between vehicles so they don't hit each other, right? So there's a ton of free space, lateral space, and longitudinal space between vehicles that currently is allocated as buffers, as safety buffers, to accommodate the limitations of human drivers. If we incentivize the exploitation of that space through higher technology, more reliable technology, and better sensors, better capabilities to maneuver, then we're incentivizing higher productivity in the system. And so I think that maybe is the most critical feature of what happens when you use a blockchain solution to set up and incentivize these kinds of things. You actually get better results, right? You actually have a system that is optimizing something of merit and value rather than something that you hope would actually improve things, but you haven't really spent the time to align incentives with outcomes.
Karl, if I'm running Ken's autonomous car manufacturing company and I'm somebody who invests heavily in LiDAR and maybe at some point radar and at some point a visual based system, and I think I've got a car that can operate by itself, doesn't need anybody outside of it telling it what it needs to do, and it essentially can't do any wrong because it's not going to hit the cars around it. Why would I look at this external system that's essentially shared trust when maybe my car can do it by itself? Or can these driverless cars do it all by themselves?
Yeah, it's a super question. I mean, can an isolated autonomous vehicle really thrive in a system? And I might argue that, if we had a really terrific race car driver, the top of the Formula One charts right now, or the top driver from the past, and I won't name anyone because I'll probably get the wrong one. But anyway, you put them in a super vehicle, and you put them on the Beltway, trying to get into Virginia from Maryland at 7:30 in the morning. I really don't feel like that even that super race car driver in the amazing vehicle would be able to get to Virginia much faster right now than me in a Honda Civic, right? Because it's not just them alone, right? The system itself is not a system in which the vehicle is alone in the utilization of the infrastructure. So if you do have such an amazing vehicle, so now leaving the race car driver metaphor behind, and moving now to an amazing autonomous vehicle, I might be super frustrated that I have all this capability, that it does sort of drive itself, and all I'm getting out of it potentially is a conversion of that time into something that is slightly more convenient from a time management perspective. I feel like the amount of investment that I might have had to make in that vehicle and the amount of investment that was required to put that vehicle on the road, that 90% of the value of that investment would be essentially nullified by the inefficiency of the traffic around it. So I think we could, in the worst case, we sort of transform the the congestion experience into something marginally more attractive. But in the best case, we can transform it into something that really almost resolves the congestion problem altogether, right? Rather than just mitigating it by making it slightly more pleasurable to, or not even slightly less problematic or dissatisfying to be in. So I might argue that if such a system existed, you should be incented to join it, and so it's sort of a system level or global good for that. It's much more efficient, but it benefits everybody. The way that Pieces of Eight, I think, tries to incentivize people to join it is that once there's a bit of a tipping point, we have enough vehicles moving. It's very hard. It would be very hard for a human driver or a disconnected machine to operate efficiently in the machine unless they're operate efficiently in the system unless they were part of that same system. I guess the point is, if you came to an intersection now and there are plenty of vehicles, or like actually the best example is after like a major sports event, you're trying to get out of the parking lot. There aren't really a lot of rules, right? So the people are doing a lot of kind of crazy driving to get out of that situation because the norms are gone, right? But it would be better if
That's a pleasant way of saying that, Karl.
yeah, the norms don't apply anymore, and so there's crazy driving, and so the point is that that's unsafe, and it's also very inefficient, and there's a lot of honking and unpleasantness. Anyways, but the point is that that's what happens when you have humans that don't have the norms to fall back on. But the reality of the situation is that number one, if we don't write the rules for the machines in the same way, so they'll essentially figure out a better way of getting out of that particular situation. And you'd want to be in the system, right? If you know everybody else's intent, you can make a plan and get out, right? If you don't know everyone else's plan, if you're disconnected from the system, whether it's the autonomous machine that is not part of Pieces of Eight, or you're just still sitting in your Model T again, you will end up being in that parking lot for much, much longer. Because you won't know how to maneuver with everybody else to get things done. The other metaphor I use is if you're a new driver, sometimes a mistake that new drivers often make is that they drive to the bottom of the on-ramp in a busy freeway and they stop. And then they try to look for a gap to get in with the vehicles going by, 35, 40, 45 miles an hour, relatively densely spaced. And it's very, very difficult for them once they get down there to get in. And everybody's experienced that, and it's hair raising, and it's also unsafe. It's a place where you can get hit easily. And they tell good drivers, right, that you want to get up to 30, 35 miles an hour at the end of that, and then maneuver in because the space is now easier to move into because you're matching the speed of the traffic next to you. Okay. So in fact, ramp meters has this effect too. I don't know if anybody out there loves or hates ramp meters, but one of the beneficial impacts of ramp meters is that they force folks to get up to speed before they enter traffic. Anyway, if you are in the system, you essentially know the gaps and can come up to speed and get into them easily. If you're not in the system, then you're guessing and trying to jump in potentially from a standstill. And so I might argue that your super machine that you just built, Ken, and spent all those billions of dollars would want to be in such a system because it allows you to exploit and maneuver in ways that demonstrate the value of your machine rather than sort of being blocked by everybody else and say, well, those crazy drivers, I wish they'd let me in.
Karl, in our last couple minutes together, I want to focus just a little bit of time on the cities. Up here in Pittsburgh, where we have an office, we have a city that has at least 40 intersections that have smart signs, smart traffic control that monitor the traffic and actually time the lights. Are we saying, or I don't know if we're actually saying this, but what are we saying about a city that makes a big investment in all of these smart traffic lights? Are we saying you're spending your money in the wrong place because you want to talk to the cars, you want the lights to talk to the lights? And it seems to me what you just described in Pieces of Eight says you don't need all of these connected traffic signals and you don't need all that infrastructure. You just need communications infrastructure.
Great point. So I think in the transition, when humans are still in the out there and maneuvering, we're going to need some sort of control system. So I'd say for the types of systems in Pittsburgh and other places that are high quality, I think those investments are still worthwhile for the next 10 to 15 years. Eventually, I believe that such systems, control systems, will be obsolete. If again we get to the sort of fruition point that I talk about, in terms of this pieces of eight or something like it becoming a ubiquitous capability, then those kinds of control systems will be gone. But what I will say is that what will be even better for the cities like Pittsburgh who invest in managing system is that there's still a role for infrastructure. And in fact, one of the things that the infrastructure might do is, rather than control, shift to a notion of inform as being the primary capability. So cars, although they have a lot of great sensors like the ones you were talking about, have a hard time seeing everything everywhere just because of the way where they're positioned, right? I mean, they're on the roadway and they're maybe 6 to 12 feet tall or something, but they can't possibly see well or see around corners. And even when they get together collectively in pieces of eight and share those heat maps of the obstacles that they collectively see and want to maneuver around, they still themselves may not be able to see everything. For example, pedestrians and other kinds of stuff moving in and around. So infrastructure that illuminates the space and helps to clarify where there are obstacles to be avoided, or people or pedestrians or anything, have a great role in terms of helping to facilitate the capability of machines to be potentially more effective, more productive, drive faster, closer to one another than they would without any help at all. So you can imagine a series of cameras pointed down on this same seven-legged intersection that we talked about before, where the 1 centimeter resolution was super fine and absolutely on target. In that case, the infrastructure itself would be like an element, a critical element in terms of allowing the machines to be much more efficient moving in and out than they were before. And in fact, the way the pieces of eight is built, one of the pieces of eight is actually that of every transaction, the value associated with it is allocated to those who manage the blockchain. But another one of the pieces of eight is allocated to the entities in the system, infrastructure or otherwise, that illuminate the space and allow for the machines to move faster. So not only is infrastructure needed and valued, but it's rewarded actually in the system by getting a proportion of every transaction that occurs in and around its jurisdiction. And so it's almost like having a self-financing infrastructure system that you wouldn't have to sort of buy and put in and hope that it's better and hope that the mayor or the governor renews the lease for or pays to upgrade. Essentially, it finances the infrastructure itself because of its value in assisting the machines to maneuver through. So in this case, we'd have sort of demand-driven infrastructure capability that informs the machines about obstacles. It doesn't exert control in the same way that we talked about with the traffic control systems, but it does have the ability to influence and improve productivity in the system and safety in the system in ways that I think are much more important, impactful, and directly rewarded based on the way that the blockchain solution allows value to be distributed among all the contributing elements.
Karl, last question for you. So far, we've been talking about driverless cars, but I've seen your presentation. This technology is much bigger than driverless cars. Can you kind of give us an idea of what other platforms are out there that can benefit from pieces of eight?
Yeah, I mean, a lot. I guess that's the bottom line. Is that although I come from a surface transportation background, and I think drivers and pedestrians and bicyclists and all that kind of stuff as a first go around, really the pieces of eight concept works just as well in three-dimensional space as it does in two-dimensional space, right? So rather than negotiating over any particular piece of roadway surface, you can imagine drones or even larger airborne vehicles or submarines negotiating over three-dimensional space in front of them in the same way so that they can maneuver around each other in ways that are both effective and productive without having to have a whole collection of human-based hierarchical rules to sort out how they should do that. And so unlocking the value and unlocking the capability of the roadway system is just one piece of it. Really, unlocking the value of any space where there might be contention for utilization, airspace, out in space, in orbit, under the water. It all essentially boils down to the same kind of problem, and that's one side for these where you have non-adversarial environments, and then there's another collection of applications on the non-civilian side that relate to how machines can learn to trust each other in a adversarial environment so that they can identify misbehavior and identify malfunction in ways that are self-organizing, in ways that are much faster than currently done, using systems that don't look like pieces of eight and don't have like this earned trust capability in them. So yeah, I feel like the door is wide open with this sort of construct to transform a number of things that a number of wicked problems that we have been struggling with over the last 50 to 70 years on the civilian side in terms of shared space, and then a whole collection of new vexing sort of head scratcher problems that come about with removing the human from direct control in the non-civilian space.
Karl, you get the last word, and I just want to congratulate you and your team and Noblis for this really incredible advancement that you've brought to the autonomous vehicle community. I'm looking forward to seeing pictures of the award ceremony in November with you in your best tux, and I really can't thank you enough for being here.
Great. Well, Ken, now that you mentioned, I have to go and see if I still fit in my tux. I haven't think I'm wear it for. I haven't worn it since I got married a couple decades ago. But yeah, thanks for the heads up on that. Yeah, we look forward to that and all the interactions. I have to say, people have been super supportive. Every place we've taken this concept, and I do hope that it has that some part of its potential can be realized. Because again, from my perspective, I feel like we have the opportunity now to do something transformative if we can get the rules of the game set up early enough that we can take advantage of it. Because I feel like there is an opportunity here. Myself, the folks at Noblis, our team will work our hardest, and we have a new demonstration of a new capability, including some of that infrastructure payment stuff that I just talked about in response to your question about Pittsburgh, Ken, that we'll be demonstrating out in Los Angeles in November at the next Moby colloquium out there. So we can intend to build more demonstrations, talk more about what we see the capability, where it goes from here, but I think we're really just depending on everybody out there to get their feedback and to try to make this as real as possible as quickly as we can.
Karl, thank you so much for being here.
It's been my pleasure.